Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is append average. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given an array A of length n and we need to perform a operation exactly k times. The operation is as follows. We will choose two distinct indices I and j, and these indices will be from 1 till n. Now once we have chosen these indices, what we can do is we need to find their average. Now if sum of the element ai and aj is even, then our average will be nothing but their sum divided by 2, and we'll append this average to our array A. Now in case the sum of our elements that we have chosen, if it is odd, we'll append the average, that will be of ai plus aj plus 1 divided by 2, so that it becomes a whole number. And then again, once we have this average, we'll append it to a. This one operation will increase the length of our array by 1. Now our goal is to find the minimum possible sum of the final array after performing this operation exactly k times. So for input format, we have t test cases, and for each test case we have two lines. The first line contains a single integer, the first line contains two spaced integers n and k, n representing the length of our array and k representing the number of operations that we need to perform. And the second line will contain n spaced integers, that will be a1, a2 till an. As for the output, in a single line we have to print a single integer, that is the minimum possible sum of the array after k possible operations. Now for the constraints, number of test cases will go from 1 to 10 raised to 5, length of our array will go from 2 to 2 into 10 raised to 5, and the value of elements in array and the number of operations k will range from 1 to 10 raised to 9. Let's see some sample inputs. So for the first sample input, we are given 5 elements and we need to perform the operation exactly one time. Let's see the array given to us. The array that we have has the elements 6, 5, 7, 4 and 7. Now, now that we want to have the sum, these numbers we cannot change. What we are going to change is going to add elements. So the elements that we are adding, we would want them to be as small as possible. So for that, when we take the average, it is best to take average of two smallest numbers. So in this case, the two smallest numbers that we have are 5 and 4. Now since the sum is 9, so we'll add 1 and divide it by 2 to get the average. That is 5. So since we only need to perform one operation, we'll add this 5 back to our array. Now if we see, the total sum of this array is 34. Next up, the second sample input that we have again has 5 elements, but this time we need to perform 2 of these operations, and the array available with us is 1, 4, 10, 8 and 1. Again in this case, since we want to append a as small number as possible, we'll choose the two smallest number and find their average. So 1 plus 1 is 2, and since 2 is even, we can directly find its average. So the average is going to be 1, and we can append it here. Since we need to perform it twice, we can again add it. Again, the two smallest numbers are just ones. We again perform the operation and add one more 1. And as you can see, the total sum of the array is 26. Let's see how we can approach the solution. Since we have seen in the sample input that it is always best for us to get the average of two smallest numbers, we will sort our array in ascending order. And now that we have sorted them in the ascending order, we can take the first element, that will be a1, and the second element a2. We can get their average and then append it. Now a simple way could be that we can perform this operation k times, because when we are finding average between two numbers, let's say a and b, the average will always be in between them. The average will never be less than a and it will never be greater than b. So our average will always lie somewhere in between. Now in case our average value is less than b, then the next operation that we perform will be between a and the average that we have found. Now in case the average is equal to b, in that case any number of times that we perform the average, all the future, the average will always be b. So it means that while we are performing k operation, there will come a time when the average that we have is going to be equal to b. No matter how many times we perform this, it will always be b. So it means that for rest of the operations, even if you don't know the average, that is, we don't calculate it, we are aware that it is going to be b. So let's say you performed I operations, right? And after I operation, you found that your average is now equal to b. It means that for all the future operations, that is k minus I, for all of these operations, you can directly add b times. So k minus I times, you can simply add b, because we know that for all the future further operations, the average is going to be this. So once we come to a consistent average, we don't need to calculate it. So this is how we are going to approach it. We are going to sort the array. Then we take the first and second element, that will be the smallest. We calculate our average. If this average is less than b, then we'll change our b to average. And in case our average becomes to be equal to b, then we know that for all the remaining operations, we can directly add b, the element, in as k minus I times. And with this, what we'll have is the minimum sum that we can get. And this is our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and k. Then we take the input of our array. And while we are taking the input, we add the elements to our answer, that is sum. Because the initial elements we cannot change. All we can do is add new elements. Now that we have the sum, we will sort our array in ascending order. With this, we can get the two smallest elements, that will be the first and second element of our array. Now that we have this, we need to perform the k operations. So while we perform the operation, we need to calculate the average. So the average is between the smallest element, in this case L and R. Now once we have the average, we check whether this average is less than our R. So if that is the case, we change our R to this average so that the next operation that we perform will be between these two smallest numbers. But in case our average is equal to R, it means that from now onwards, whatever average operation we perform, it is going to be the same. It will always give us R. So in that case, there is no need to calculate it. We know exactly that k minus I plus 1 times will get average, because this is the remaining number of operations that we need to perform. Now once we do this, we have performed exactly k such operations, and we have a valid answer for our sum. The sum is the minimum value that we can get by performing these exact k operations. And as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and k, then we take the input of our array and sort it in ascending order. Once we have sorted this, we need to find the two smallest numbers, namely n, l and r. These are the first and second numbers. Then we need to find average k times. But as we have seen in the approach, we don't need to perform exact k operations. While we are performing the average operations, if our average value is equal to r, that is our upper bound, we know that going forward, any average operation is going to give us the same average. So for all the remaining operations until we reach k, this is our average, and that many times we add it to our sum. At the end, we print our sum, and as you can see, I've got an AC in my Python implementation. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.